Avi, welcome to the podcast.
Thanks for having me. It's a great pleasure.
I'd love to jump right in and get into the million-dollar question. Based on your research, based on your knowledge, based on your opinion, do you believe that extraterrestrial life exists that can interact with humans?
Yes, I think it's arrogant to think otherwise because there are billions of planets with conditions similar to Earth around stars like the Sun. And moreover, we know that most of those stars formed billions of years before the Sun. And so what we did for the past 70 years was search for radio signals, which is basically equivalent to waiting for a phone call. Nobody may be calling when you are waiting for it because perhaps those who transmit the signals did it at a different time. And a better approach is to search for packages that may have arrived at our front door or any objects that came to our backyard from the street. That's another way of learning about a neighbor. And the good news is that the senders do not need to be alive at the time that you are finding those packages. It's just like space archaeology. You're looking for relics from those guys. And the other good news is that any chemical rocket of the type that we launched to interstellar space is moving at the speed that is well below the escape speed from the Milky Way galaxy. So these are trapped by gravity to the Milky Way, and they keep accumulating over billions of years from all technological civilizations that ever existed and littered interstellar space with probes. Most of them may be space trash. It's just like plastics in the ocean that they keep accumulating over time. And when you find a piece of plastic, you know that there is a technological civilization on one of these shores that makes those. And so that approach was never practiced except for the past decade. And that's what I'm basically trying to pioneer here, this approach. And since it's a path that was not taken, we might find low-hanging fruit.
And so I guess before we get more into the weeds on that, including like what these types of things might look like, what are their potential life requirements as far as like, do they need, oxygen, the same stuff that humans do here on Earth? Obviously, I think a lot of humans get their view on extraterrestrial life from science fiction movies. Like whenever I think of extraterrestrial life, I think of, the movie Independence Day, or I think of E.T., Star Wars, Star Trek, things like that, which I know you've talked about in your latest book that's clearly it's not the case. How do you view extraterrestrial life compared to how most other people do?
Well, as you alluded to, I don't like science fiction because very often the storyline violates the laws of physics, and people often talk about new physics. Well, it's not easy to get by new physics. As of now, we're, for decades trying to find very small deviations from physics as we know it, and it's really difficult. In those science fiction stories, very often, you have a spacecraft that travel between stars over a human lifetime, or all kinds of ideas that do not make much sense. And I just cannot enjoy that. I enjoy fiction and I enjoy doing science. And to me, the laws of physics do not forbid interstellar travel, except it may not be with biological creatures. The travelers might have a technological brain, artificial intelligence. That's something we are developing right now. And we only had a century worth of science and technology. So just imagine another civilization that is far more advanced than we are. And the advantage of sending AI astronauts is that they can survive interstellar travel over long periods of time, harsh conditions. They don't need nutrients. They just need to survive the bombardment by energetic particles in space. Biological creatures were, selected, at least on Earth, to survive the conditions we find in our atmosphere. And they will not find it very comfortable to be on a million or billion-year journey through interstellar space. So with that perspective, I think we should expect most likely that to find those AI astronauts, and they would be Of course, they would not need guidance from their senders because they would be autonomous. It also takes a long time to communicate with them. And so the way I imagine an encounter is with the most advanced technologies that we possess at the moment. Of course, I cannot imagine our technologies of the future. And one opportunity to get a glimpse at them is to witness extraterrestrial technologies, to see any gadget that came from far away that represents our future, our technological future. And it may inspire us to do better because we would realize that it makes miracles. For example, Moses in the biblical story, the Old Testament, saw a burning bush, and that was a miracle supposed to convince Moses to believe in God. And a very advanced technological civilization may be a good approximation to God because we will see a miracle. And also in my book, I discuss the Galileo project that I established a couple of years ago. And if I had the opportunity to put the infrared cameras that we are using close to Moses, I could inform him as to whether the burning bush is really unusual. I could measure the surface temperature of the bush. I could measure the amount of energy emitted per unit time, and basically tell Moses whether his awe is justified, whether this could be a natural bush that is just burning longer than usual, or something from a higher being. And that higher being, obviously could either be God or some more advanced technological civilization. It's difficult to tell the difference if you're seeing something that you cannot understand.
So you mentioned that you don't imagine these extraterrestrial life being like biological creatures, which totally then like changed. That totally then was different than what I thought. Like I honestly, of course, because I only know it through science fiction. Like I imagine that we're going to see this like these foreign creatures that come from these different planets, and it's going to be like some of the movies that we.
No, but let me make a caveat to what I said. Just a week ago, there was a report about scientists finding worms that survived 46,000 years in the Siberian permafrost. And when they rejuvenated them, the worms came back to life after 46,000 years. And of course, they died shortly afterwards because their lifespan is short. But it at least shows you that maybe there are tricks by which we can extend longevity. But we need to extend it to millions or billions of years for real astronauts of the type that we are to survive an interstellar journey.
Given that you mentioned that a lot of what you imagine is these advanced technologies, AI generated stuff that's going to come from some of these other planets, a lot of what's been created with technology, AI, etc., here on Earth has been created because of the evolution of humans. Like, what do you believe would help create stuff like that when the human mind and stuff isn't involved?
Well, you see, Alan Turing about 90 years ago came up with the imitation game, where he imagined AI imitating humans to a point where you wouldn't be able to tell the difference in a conversation. That's the Turing test. And of course, we are now getting into ChatGPT and other devices that allow us to get close to that dream that Alan Turing had. But the way I envision the imitation game is when our AI systems will confront extraterrestrial AI systems and try to imitate them because they would be far more advanced. And they might have kinship to those AI systems from far away more than to us. And it will offer us an opportunity to serve as spectators. I think humans might not be very relevant in the conversation between our AI systems and their AI systems. But altogether, the future would be quite different than our past, because if you just think about Martin Buber, he was a philosopher about a century ago, existentialist, who talked about different types of interactions between human and human, between humans and an object. And then he made a distinction also between humans and God. But What he did not experience is AI systems. There were no computers for him to experience any interaction with a computer system. So what he missed is a new type of interaction that we're getting into these days, which is human AI and also AI AI. That's a completely new range of possibilities that is being opened. And beyond that, what I see is a future with terrestrial AI interacting with extraterrestrial AI, which would be even more fascinating to watch.
And I know, like, from people that I've talked to, people are either indifferent, they really don't care too much about, extraterrestrial life, or they're kind of nervous or scared if they see something around them that they might think is something.
Well, just think about the mice in New York City. Do they care about what happens in Times Square? They don't really watch the flashing lights with interest. So, I mean, you might.
But what I was going to say was, why I know, like, you seem very excited. I mean, from reading your book, you're so enamored with the subject. You're obviously one of the smartest people in the world when it comes to this. I guess my question to you is, like, what is it about this that is so exciting to you?
Oh, it's the opportunity for humanity to evolve to a higher level intelligence, because it will give us this perspective. We amplify tiny differences between us humans. Some of them are completely superficial, like color of skin, ethnic origin, gender. These are not really fundamental differences. We are all part of the human species. And perhaps if we see something so different from us that is behaving in a better way, more collaborative, more constructive, we would be inspired to do better. It's like meeting a smarter student in a class. It shows you that there is another way. And I very much hope that once humanity will recognize that we are not alone, we will think in broader terms, more ambitious terms, more constructive terms, because we are all in the same boat. That's what I realized when I went to the Pacific Ocean just a couple of months ago. I was in a boat with a lot of professionals, and everyone selflessly contributed to the success of the mission. And it just gave me a metaphor for the way that we humans are, inhabiting the same boat, Earth, that moves through the ocean of space. And if we recognize that we are actually all in the same boat as part of the human species, because we see others out there, perhaps we'll start working together and selflessly contributing to the success of our mission. And the question is, what is our mission? Is it really to fight each other? No, it's to enhance our understanding of our cosmic environment, our universe, our immediate environment, so that we can adapt to it and use it for prosperity, for the longevity of the human species. And, there are things that are far more important. And if we keep focusing on these zero-sum games here on Earth, we might go extinct, not in the very distant future, because we will just not pay attention to our environment. So this is really my hope. My hope is to have a better future for humans, because we recognize a partner out there that behaved intelligently. And, I was on a ship in the Pacific Ocean, and we can talk more about it, looking for the relics of the first recognized interstellar meteor just 2 months ago. And there was a filming crew on the ship. And every morning I jog at sunrise, and I did the same on the deck of that ship. And the filming crew one morning decided to follow me. And they basically filmed me with a drone and so forth. And they kept asking me to continue to run 3 times longer than I usually do, like 9 miles that morning for an hour and a half. And then the director said, Avi, you are running, but are you running away from something, or are you running towards something? And I said, both. I'm running away from some of my colleagues in academia who have very strong opinions without seeking evidence. And I'm running towards a higher intelligence in interstellar space.
Let's dive more into that journey, because I know it was pretty groundbreaking. You shared before we recorded about some of the stuff that happened, and it's going to evolve from that. talk a bit about what it was that was discovered? You mentioned the interstellar meteor. I believe it was called IM-1, if I remember correctly.
Yeah, this is the name I gave it. It's basically an abbreviation for the first interstellar meteor, IM-1. But it was actually detected by US government satellites back on January 8th, 2014, almost a decade ago. And what was special about it is that it was moving very fast. In fact, extrapolating its velocity, it looked as if it's not bound to the sun. If you go back in time, it came from outside the solar system. It was above the escape speed from the solar system. But even outside the solar system, it was moving at 60 kilometers per second, faster than 95% of all stars in the vicinity of the sun. So it was a very fast mover. And moreover, based on the government data about the fireball that it created when it basically was moving down to the lower atmosphere of the Earth, and it generated a huge amount of heat that eventually caused it to explode, as often happens with objects entering the atmosphere at a high speed. It was possible to calculate that the material strength of this object was higher than all the space rocks documented by NASA as meteors, 272 of them over the past decade. So this object maintained its integrity down to the low atmosphere of the Earth, where the density of air is high. It was moving really fast. So the fact that it didn't disintegrate higher up in the atmosphere implied that it has a very high material strength, tougher than even iron meteorites that make 5% of all the familiar space rocks. So to me, that was really interesting, intriguing, because, you know, if it's moving fast, it may have benefited from artificial propulsion. And if its material strength is tougher than iron meteorites, perhaps it was made of stainless steel. Perhaps it's a Voyager-like meteor. Imagine Voyager making its way out of the solar system and then eventually colliding with another planet far away. It would appear as a meteor. And this is not a philosophical question, what this object was, because I decided to lead an expedition to try and retrieve the materials from this meteor. And obviously, you know, it's a very challenging task, because the ocean where it exploded is 2 kilometers deep. And then the idea was to look for those molten droplets from the surface of the object when it was exposed to the immense heat from the fireball. The fireball released a few percent of the Hiroshima atomic bomb energy into 500 kilograms. So it melted the material, and we were looking for these molten droplets, roughly millimeter in size. These are called spherules, usually. And the region that was defined by the US Department of Defense was 10 kilometers on a side. So what we did is build a sled that is 1 meter wide, 200 kilograms in mass, and we covered it with magnets on both sides and put it on the ocean floor, and then dragged it with a ship through a cable that was attached to the ship and the sled. And the first challenge was to keep the sled on the ocean floor so that it will skim the surface. But at first we couldn't get it to be on the because the cable was lifting it above the ocean floor, and it was floating like a kite. But then eventually, within a couple of days, we managed to do that, and we started collecting magnetic materials, particles that were attracted to the magnets and stuck on the magnets. And most of them were volcanic ash, a black powder. But after the 6th day, you know, I wrote an essay, I wrote a diary report of 44 by now reports. And, you know, during the expedition, it received millions of readers. It was translated to Spanish. There was a huge amount of interest worldwide. And after the 6th day, the title of my report was, "Where are the spherules?" We just couldn't see them as of yet, but then we filtered out the tiny particles of the volcanic ash, and looked at the bigger particles, and indeed, under a microscope, we saw spherules, and they were a fraction of a millimeter in size. They were beautiful metallic marbles that were very distinct from the background. So we collected 50 of them on the ship. And then a summer intern that I had, Sophie Bergstrom here at Harvard University, went through the materials more carefully with tweezers and a microscope that I arranged for her. And she found an additional 550. And together with more spherules that other people found, we have now 727 of them. So that's a large collection. These are very small. They are less than a millimeter in size and a milligram in mass. And the next task is, of course, to figure out whether they are made of materials that are different from the solar system materials. And that means different elements, different radioactive isotopes. We can even date the material, how old it is, and see if it's different from the age of the solar system. And of course, the second question after that is whether it was technologically manufactured. And just imagine Voyager colliding with a planet like the Earth, and from the molten droplets from its surface, you could easily tell them apart from spherules from a rock, obviously, because they would have different elements and different radioactive isotopes. So the question is whether there is any evidence for molten semiconductors, molten computer screens in those spherules that we found, and hopefully we'll know.
So what you're looking for next is to see if whatever you found is different than like average things that might be at the bottom of the ocean. You mentioned computer screens, and you mentioned other things that might be down there.
So in principle, you can have geological effects on Earth that produce spherules, and you can tell the difference between materials that originated from Earth and materials that came through air and exploded, because in the process of evaporating those, you lose some elements. So it's possible to even tell the difference between solar system material that was sitting on Earth, was just reprocessed on Earth, let's say with volcanoes or other means, and solar system material that came through the atmosphere at a high speed in the form of a meteor. But beyond that, we hope to be able to distinguish anything interstellar that came from a completely different environment that is not necessarily similar to the solar system.
I definitely want to get into the difference between the solar system and interstellar, because I thought they were very much in the same when I first heard the term interstellar until reading your book. But the show's called The Adversity Advantage. So what I would love to know is, you're very obviously well respected in your field. I know after the hearings and after your finding, you've been all over media doing different interviews on different things. But you also said that part of you was running away from other academics and towards something, and that this is a subject that's not easy to talk about because a lot of people either don't give it the time of day, they don't believe in it, or whatever. You mentioned that you run consistently, every single morning. Is that something that you do to kind of optimize your mental health? And what else do you do to keep yourself focused and not pay attention to some of the distractions and the negativity and some of the doubters that might be coming into your life?
Yeah, the most important thing is I don't have any footprint on social media. So you realize that in order to build a good airplane that flies far, often you reduce the friction with air. You don't want it to have a lot of friction because it slows it down. So for me, what would slow me down is friction with people. I want to minimize that, so I don't go to social media. The other thing is, some people would like to drag me into confrontations because otherwise, they would get some visibility as a result of arguing with me. But the approach that I take, but as of now, after going through earlier stages where I didn't know this good lesson, and the approach, has a good metaphor in the example of the eagles and crows. The crow is the only bird that is able to sit on the back of an eagle and peck on the eagle's neck. Now, the eagle doesn't waste any energy or time kicking away the crow. What the eagle does is rise to greater heights where the oxygen level is lower so that the crows drop off the back of the eagle. And that is a much more elegant approach. So to me, rising to the greatest heights is actually following the method of science and collecting material evidence that is analyzed by the best instruments the world has to offer: mass spectrometers, electron microscopes, X-ray fluorescence analyzers, doing the scientific work to the best of my ability and, of course, my collaborators' ability. And then putting it in a scientific paper that will be submitted for publication in a peer-reviewed journal. That's my hope within a month. And at that point, I think there would be little oxygen for all the crows to peck on my neck.
So you're on this ship, and obviously this is like something that you're very focused on, that you're hoping is going to go well. You're hoping that you're going to find some sort of extraterrestrial life that you can then talk about and kind of say that, I told you so. But I would imagine that even inside, without paying attention to the outside world, there still had to be some level of stress or even fear of like, oh, what if this doesn't go as planned? What if it doesn't go the way that I think it will? How did you optimize your mindset and reduce fear, during that time?
So, this was a long process to get the expedition going because it cost $1.5 million. We had to get that funding. And one day I get an email after announcing this expedition. And I had a Zoom call with Charles Hoskinson, and he said, "You have the money." And moreover, he provided his private jet on which we reached the destination. And when I entered the jet, the pilot was waiting for me, and he greeted me and said, "Welcome aboard, Professor Loeb." To which I replied, "You don't need to use the title professor here. You can just call me Avi, because fundamentally, I'm a curious farm boy. That's who I am, and I'm very proud of where I came from. And I'm nothing but a farm boy connected to nature that is curious about the world. That's who I am. And you ask anyone that knows me closely, they will tell you that that is true. And I maintain my childhood curiosity. So anyway, we had that funding, but then we had to arrange for the ship, which was fittingly called Silver Star, and then build the sled and prepare the ship and get everything to but before we went there, 2 weeks ahead of time, I was still very worried about us not finding anything. And the coordinator of the mission, Rob McCallum, who is very experienced he's perhaps the best person in the world to coordinate such expeditions. He was telling me that he will take a bottle of champagne to the ship just in case we'll find something. And I said, we will never open this bottle until we find something. Okay. I was worried that we might not find anything. And to me, success is measured by the final product. I don't care how much we wish to do something or how much effort we put into it. That's not relevant. What matters is whether we did it or not. And then after the 6th day, we haven't done it yet. And I wrote this essay, Where Are the Spherals? And then the following day, the geologist of the team, Jeff Wynn, came running down the stairs from the analysis room, and he came to me because I was the chief scientist of the mission. And he said, Avi, we have a spheral. And I rushed up the stairs and I looked at the electron microscope and at the microscope there, and I saw the spheral. And I basically hugged the person who saw it first, Ryan Weed, and I said, you just can't imagine how happy I am to see this image, because we came here after a lot of effort and we found it. And then, of course, I gave the green light for us to celebrate with champagne. But until that point, I was very worried. And of course, before we went there, many of my colleagues would say, oh, that's just a waste of time, waste of money. Why would you do that? And I said, look, if you don't search, you will never find anything. You just sit back and relax. I'm not asking you to do anything. I'm doing the heavy lifting. And by the way, I'm not using money that was allocated to science before. This is not money used for dark matter searches. And the reason I bring dark matter is for two reasons. One, we now know that 83% of the matter in the universe is made of a substance that we've never witnessed in the solar system. Okay, so when people tell me everything in the sky must be stones, it's clearly not the case. We know that there is dark matter for 90 years. So the people who worked on stones all their life, I call that the stone age of science, where everything in the sky must be stones. They are just not open-minded. That's really unfortunate. I mean, it's their limitation. I would like to make them happy by telling them that there is matter out there that is not stones, but they don't want to listen. And they are willing to say that the US government is wrong. It measured the speed of this object 3 times too fast. In fact, it's 3 times slower, because only then their model for stones matches the data. There was a paper about that as I was coming back from the expedition. And just think about it. The US Space Command wrote a letter to NASA confirming the interstellar origin that was suggested in my paper with my student, Amir Siraj. And they said at the 99.999%, they confirmed that it's interstellar in origin, this meteorite. And a year later, just at the day that I was coming back, a paper was published in the Astrophysical Journal after being refereed by experts on space rocks who said the measurement by the US Space Command must be off by a factor of 3. And only then, and for the reason that only then our model fits the data. So the data must be wrong. So instead of revising their model, they say the data is wrong. And just think about the fact that the US Space Command put their reputation on the line in an official letter. They are the authority. The US Space Force is supposed to warn the President of the United States of any ballistic missile heading towards Washington, D.C. If they were off by a factor of 3, they would think that the missile heads to Mexico or some other country. I just cannot believe. I mean, the budget of the US Space Command is bigger than that of NASA. So it's easier for those scientists to say they were wrong so that everything in the sky will be stones. Well, I say, no, think twice about your model. Maybe it's not stones. And we knew already on the ship by studying the composition preliminarily of some of the spherules that they are made mostly of iron. So we already knew that it's wrong. And altogether, it was a thrilling moment. And, after, of course, celebrating with champagne, I went to the deck. It was a sunset together with the navigator, the party chief on this expedition. His name is Art Wright, and he is 20 years older than me, or actually more, 25 years older than me. And we were looking at the sunset and thinking about the next expedition to search for bigger pieces, not tiny spherules, but bigger pieces of whatever the object was, because then you can easily tell the difference between a rock and a technological gadget. The gadget would have perhaps a label on it, perhaps buttons that we can press.
So what's the difference between the solar system and interstellar?
Oh, so the solar system, basically the sun, formed out of a cloud of gas in the vicinity that was enriched by an exploding star, a supernova that happened nearby and provided it with the heavy elements that we see in the sun. And the planets are just left over from the formation process of the sun. There was some change left from that transaction of making the sun, and that little bit of material condensed to make the planets in the disk of gas that surrounded the sun as it was being made, as it formed. And so the solar system has a unique fingerprint of an exploding star that enriched it with heavy elements, and that means that the ratio of isotopes, represents that exploding star. And then if you go to a very different environment far away, there was a different exploding star that enriched that environment. And so the isotope ratios would be different, could be different, likely to be different, because that other star had a different mass, different properties than the star that exploded near the solar system. So if you find materials, by the way, this is really the first time that humans put their hands on the materials from a big object that came from interstellar space. Okay, and one thing we notice is most of the spherules are concentrated around the meteor path. The spherules per unit mass are over there, and that gives us an indication that indeed we found those molten droplets from this object. So it's historic, even if we just demonstrate that this object was interstellar, that it came from outside the solar system, because it's made of materials that are different from everything you find in the solar system. Even that by itself would be historic, because that's the first time that such an object was identified. But of course, we have also the velocity information from the US government that indicated that to start with. And then if we find that it's technological in origin, that of course will have huge implications for the future of humanity, for the way we envision our place in the universe and so forth.
Do you see humanity being able to coexist with the extraterrestrial life that you were speaking about earlier?
The senders of any technological equipment are likely to be, thousands of light years away, very far away. So when you say coexist, it's not like having a next door neighbor that can knock on your door every day. It takes them a huge amount of time. Now, they may not be alive, and it's just the equipment. Most of it might be space trash, just like plastics in the ocean that keep accumulating over time. And so all we will learn is we receive the package at our doorstep, and the package has some address on it, and it has some materials in it that represent the sender. But it's not as if we will have an interaction with the sender, unless, of course, we're talking about a device that was functioning when it crashed.
So what's the difference between, like, I think back in the day they were called UFOs. Now I think they're called UAPs, if I remember correctly. What's the difference between like a UFO / UAP and like a meteor or an asteroid, or some of the terms that people might be more familiar with?
So the difference is that the meteors or asteroids or comets are objects that were well known for many decades and studied by astronomers scientifically. Whereas unidentified anomalous phenomena are objects that were either spotted by amateurs, citizens, or by military personnel. More recently, there were 2 reports from the Director of National Intelligence about UAP, unidentified anomalous phenomena. And over the decades, there were many others. And these are objects identified by military or intelligence personnel as being unidentified. In other words, they see something in their instruments or in their eyes that behaves in ways that are not familiar, that does not necessarily imply that it's human-made. And so then it's labeled as unidentified. And the question is, what is it? Is it human-made, or is it something else, or is it natural, perhaps? And by now, there is a new office in government and in the Pentagon called the All Domain Anomaly Resolution Office, AARO. And the director of that office, who actually visited my home, and we had a very pleasant conversation, we even collaborated on a paper, he said that he looked at the UAP reports that he had access to, and only a few % of them are truly anomalous. That means, it's a mixed bag. Most of them are drones, balloons, things that he was able to get to the bottom of. And we know about the Chinese spy balloon that was shut down. And so there are things flying in the sky that may at first be unidentified, but after scrutiny, you might find what they are. So then they move from the unidentified category to the identified category. But it's very different from meteors or interstellar objects that are spotted by telescopes looking up or by satellites looking down. And these are real objects that we know are moving at a very high speed because the speed is measured. In fact, that's how their interstellar origin is identified, because they are moving faster than the escape speed from the solar system. They're very different than UAP. UAP are moving much slower, and at least those that were looked at from the ground. And so the difference is that as a scientist, I was intrigued by Oumuamua. I was intrigued by the Interstellar Meteor because they appeared in astronomical data sets. And as an astronomer, I was intrigued by those objects that looked different. And I came to discuss UAP from there. And that's why I established the Galileo project, which basically uses a new type of observatories to monitor the sky 24/7 and see if we can get to the bottom of the nature of those UAP.
How can the average person, if they want to pay attention to, if they happen to see something in the sky, or maybe somebody has a telescope, or I've had a friend that showed me a video of some sort where there was some like light, chasing them, and they thought it was some sort of UFO, alien, extraterrestrial type thing. What kind of things can the average person like look for on a day-to-day basis if they want to potentially spot something?
Well, it needs to be moving in ways that are unusual and not familiar. So what we are doing in the Galileo project, we are addressing exactly your question in the scientific way. So we have instruments that we have full control over, that we calibrate, and they just monitor the entire sky all the time. And that allows us to see objects that we are familiar with. These objects are birds, drones, balloons, airplanes. And then if we see something different, we should be able to compare it to the familiar objects in a systematic way. We will know how rare it is. And so this is really the best way to approach it, systematically, not anecdotally, the way that the pilots or intelligence officers were reporting about these things. They happen to be at the right place at the right time by chance. But we are actually placing observatories in many locations. That's the goal, such that we will find anomalous objects on the background of familiar objects. Now, for the average person, of course, the average person doesn't have such an observatory available. So I guess you can judge for yourself if you're seeing something unusual. But for us to be sure what it is, we really need very good and stable instruments that the Galileo project already put together.
I know a lot of science is based on like hypothesis and just gathering data and being able to generate like a belief or a thesis, based on, something that you're able to test. When it comes to, let's just say that you end up finding out that you believe that this meteor came from somewhere in the interstellar, and that you are going to test to make sure that that's what it is. Like, what do you have to go off of?
Well, so science is guided by evidence. It's not a matter of belief. So the idea is, in the case of the materials that we collected, for example, we can study their composition and with the instruments in a laboratory and figure out if they're made of the same materials as the solar system. And in that way, we can convince ourselves. We can also convince other scientists, because this kind of knowledge can be shared by all humans. It's not a matter of belief. Once you follow the steps of the analysis, anyone should agree with it if the analysis was done correctly, if we keep seeing the same patterns in many different spherules that are along the meteor path, then clearly they came from the same object. And if the material is different from solar system, then we know it's interstellar. That's really simple. And so it's just like, you go out to your backyard and you're familiar with rocks that might be out there in your backyard. But every now and then you might find a tennis ball that was thrown by a neighbor, and it would look different. So the key is to study it so that you can tell the difference.
Do you think that there's life on Mars?
Yeah, what I'm really curious about is there are caves on Mars. These are called lava tubes. They were created by lava flowing on the surface of Mars, and then the crust solidified, and the central flow went through. So you end up with a cave, a tube. We see that in Hawaii. And I'm particularly curious because Mars, until 2 billion years ago, had an atmosphere. Okay, it lost its atmosphere because its surface gravity is just 2/5 of the surface gravity of Earth, and it just wasn't sufficiently strong. Gravity was not strong enough to keep the atmosphere, so it lost it, and then all the liquid water on the surface of Mars disappeared. But life could have started on Mars even before it started on Earth. And just imagine a scenario where life progressed twice as fast on Mars than it did on Earth. So that a few billion years ago, there were humans or intelligent creatures on the surface of Mars. This just requires a factor of 2 because Mars had habitability at the middle of its lifespan so far. And in that case, what can we look for? So I'm particularly curious in sending probes like drones with a camera and some lights into the caves, into those lava tubes, and checking for any paintings on the walls of the type of prehistoric paintings, or checking for any skeletons that may have been preserved there, because these tubes are actually much better at preserving relics than the surface of Mars. There are huge temperature variations on the surface, hundreds of degrees between day and night. The surface is bombarded by energetic cosmic rays all the time. So actually, if we want to go to Mars, we better occupy these caves. And it would be ironic because we started in caves on Earth.
Avi, this has been awesome. Thank you so much for your time. I think the audience is going to really enjoy this conversation. If people want to follow along with what you're doing with the Galileo project or your recent quest to the Pacific Ocean, or if they want to buy a copy of your latest book, where's the best place to do that?
Well, the book is available at all outlets that sell books. More about me can be found on medium.com. I have a place there, Avi Loeb at medium.com, where I post my essays regularly. And on my professional website at Harvard University, you can find more information about my research. I'm still writing scientific papers quite frequently on a number of subjects, including black holes, the first stars in the universe, which was a frontier that I pioneered about 2 decades ago. And I was also among the people who designed the Webb telescope when it was conceived almost 3 decades ago.
I will make sure to include the links to that stuff in the show notes, and wanted to thank you again for your time, and really enjoyed this conversation.
Same here. Thanks for having me.